day everyone. Today, we will discuss about earthquake, rocks, and soil. A 7.2 magnitude earthquake hit Bohol on October 15, 2013. Buildings and roads were destroyed, and animal and human lives were lost. Official reports by the National Disaster Risk Reduction and Management Council, or NDRRMC, disclosed that about 200 people were dead, 8 were missing, and 976 people were injured. Why do earthquakes occur? How are they generated? What is an earthquake? Many of us have experienced earthquakes, from feeble shaking to violent trembling of the ground. But what really is an earthquake? The branch of geology that studies earthquakes is called seismology. Earthquakes are shaking of the ground due to the movement of rocks underneath. The shaking may range from weak to very strong tremors. There are about 1 million earthquakes occurring in the world every year. Most tremors are so weak that we do not feel them. Once in a while, we witness strong tremors that cause major destructions to the environment. Forces acting on rocks transfer energy to them. The energy is stored and released only when rocks move. The most common cause of earthquakes is faulting. Imagine a compressional force pushing on rock slabs, usually along fault zones. The rock slabs store this energy until one day there is enough force to move the rocks. As the rock moves, the energy it has stored for a long time is released to the neighboring rocks. Like a rifle in a pan, the energy is passed on from rock to rock in all directions until it reaches the Earth's surface. This is how earthquakes are generated. Earthquakes originate under the Earth's surface. The origin of an earthquake is called the focus. The area on the Earth's surface directly above the focus is the epicenter. The tremors are sent out in all directions from the focus in the form of seismic waves. Seismic waves behave just like water waves or ripples when you throw a stone into a pond. A single disturbance in the water spreads in all directions in just a few seconds. The same thing happens when rocks move under the Earth's surface. A single movement releases energy to the surrounding rocks, spreading in all directions. Kinds of seismic waves. Seismic waves are classified into primary waves and secondary waves. Primary waves are the first to arrive at the Earth's surface. It can travel through solid, liquid, and gas. Studies show that primary waves push and pull on the particles of rocks as they move. Secondary waves were observed to move particles of rocks from side to side or up and down. It can only travel through solids. When primary and secondary waves reach the Earth's surface, they form surface waves. Surface waves are the slowest, but they cause a lot of destruction since they make the ground roll and move from side to side. This is what topples buildings and cause lateral movements along the Earth's surface. After strong tremor, you must have seen photos of road sections moving to one side. Since seismic waves carry energy, this energy is transferred to the ground through which they travel, resulting to changes in the Earth's crust and damage to property. The images shown are just a few of the damages brought about by a strong earthquake. The side-to-side motion of surface waves cause lateral movement of the ground, toppling buildings and causing wide cracks on roads. There are also earthquakes that occur on the ocean floor. This could result to the formation of giant sea waves called tsunamis. An earthquake originating from the ocean floor can cause water waves to move at high speeds reaching up to 800 km per hour. In the open sea, the waves appear just like the other waves. But as it moves towards land, the fast-speeding waves tend to pile up until waves over 10 meters tall wash over the shore and reach up to over 5 kilometers inland. The March 11, 2011 earthquake of Japan was said to have tsunami waves about 40 meters tall and reach about 10 kilometers inland. Measuring earthquakes. An instrument used to detect and measure earthquakes is called a seismograph. A record of the earthquake waves is called a seismograph. It contains wavy lines of varying heights. The higher the wavy lines are, the stronger is the earthquake. The highest wavy lines are used to find the strength or the magnitude of an earthquake. The terms magnitude and intensity are used to describe earthquakes. Magnitude is the energy released by an earthquake. This is measured by the Richter scale, a mathematical formula which rates the size of seismic waves based on the energy release. Those rated 5 and below are small quakes that are felt by a few. Those rated 5 and above are strong ones and are felt by many and cause destruction in some areas. The Mercalli scale is made up of 12 steps that describe the intensity of an earthquake. It tells about the strength of ground, motion, and its effect on people, structures, and the environment or the damage done by an earthquake. The higher the number in the scale, the greater the damage done by an earthquake. But modern monitoring of earthquakes use the moment magnitude scale, which is more accurate than the two scales because it calculates time, location, and movement of the Earth's crust. This scale can also measure a range of waves from strongest to weakest. Today, earthquake monitoring and recording applies modern technology using computers with electronic sensors, amplifiers, and recording devices. The instruments can detect a broad range of high-frequency waves and can detect ground movements, which we humans cannot easily observe. It also uses GPS or global positioning satellite systems to gather seismic data. Satellites send signals to the ground station at the pivot to report on even slight movements of the Earth's crust. In the Philippines, the government agency responsible for the monitoring and earthquakes and volcanic activities is the PHIVOLCS, or the Philippine Institute of Volcanology and Seismology. The PHIVOLCS has circulated an earthquake advisory which they want everyone in the Philippines to know about. The agency believes that educating the people is the best way of limiting casualties and preparing the nation for the hazards earthquakes can bring. The PHIVOLCS Earthquake Intensity Scale, also known as PEIS, tells about the effects of the tremors in an area, its effect on people, objects, structure, and surroundings. Rocks